Rates of change is just a fancy way of describing anything that changes with time. And so in terms of what we're looking at today, it means we're going to be differentiating with respect to t for time rather than the normal x. Now, these rates of change questions are generally about how to find one rate of change from another associated rate of change, e.g. things like length, area and volume that are all associated. In order to do these questions, we need two things. We need to know the rate of change of one of those variables, and we need to know the formula that links those variables. And then what we're going to do is make a link between the different rates of change using the chain rule. So for example, here linking area and length to get the rate of change of the length, knowing what the rate of change of the area is, we're just going to use this chain rule here. So we've got dA by dL times by dL by dt. So you've seen this chain rule before. So let's do an example. So here we're given the formula for a volume of a sphere, which is 4/3 pi r cubed. And we're told that the sphere is expanding at a constant rate of 20 centimeters cubed per second. And we need to find the rate at which the radius is changing. So what do we know? We know the formula is V equals 4/3 pi r cubed, and what we know is that dV dt equals 20. So we need to link dV dt to dr dt. So we've got dV dt will be equal to dV dr times by dr dt, which is what we're trying to find. So we know that dV dt is 20. So now we need to differentiate using this equation here. So hopefully you can see, so we multiply by the 3, so the third element goes away. So we're going to have 4 pi r squared times by dr dt. So all we've got to do now is rearrange so that we have dr dt on its own. So we'll have dr dt equals 20 divided by 4 pi r squared, and that we can simplify to 5 over pi r squared.